All right, so here we go. What were we doing? We were doing this. We were doing this. Okay, so absolute value again is the distance from zero. We need to look at what is the distance from zero. What values are 5 away from zero? That's number one. Let's look at number two. This is a little bit different, right? But let's refer it back to here. Okay, notice how we took the equation. Okay, we took the equation. We took and we said, okay, the stuff here was equal to the stuff on the right. Okay, and we took the stuff on the inside of the absolute values, and we said it was equal to the negative number. Does that make sense? That's what we're going to do over here. We're going to take the stuff on the inside, the stuff on the inside. We're going to say that it's equal to what it's equal to, positive 5 in this case. Then we're going to take that stuff on the inside, and we're going to say that it's equal to the opposite of it, or negative 5. Does that make sense? You guys with me? Doesn't that match what we kind of did here? It's except the stuff in the blue is a little bit different. Okay, so right now we're going to turn around, and I'm just going to copy down the stuff in the blue. Copy it down. That's actually the setup for the problem. We're going to put an or there. Okay, and we actually have two problems to solve. Okay, so we're going to turn around and we can add 5 to both sides on the first one, and we get x is 10, right? Or add 5 to both sides, we get x is 0. By the way, those are the two numbers that you guys came up with on the warm-up. Remember that? That's another way to do that same one on the warm-up, but kind of just a more regimented way, a specific way, just with a process, instead of just problem solving, just reading it and thinking. Okay? That makes sense? Let's do it again. Go ahead and copy these down. Okay, go ahead and copy these down. We're going to do number 3. What two answers did we say? We said it was 2 and negative. We said that those were the two answers on the warm-up when you guys just looked at it and tried to guess and check and problem solve it. So we need to get to those two answers. And it's very similar to how we do on number 2. We take our stuff on the inside. We're going to take this stuff on the inside. It's equal to 5. Or we're going to take this stuff on the inside. We're going to say it's equal to negative 5. Okay? But that stuff has changed in this particular problem. That stuff is the 2x plus 1. So we're going to put 2x plus 1 in there. We're going to put 2x plus 1 in there. Right? And we have two equations to solve, and hopefully we'll get two different answers, x or negative 3. Okay? Now we're going to solve this two equations. So we're going to minus 1 minus 1. We get 2x equals to 4. Keep solving. And guess what we get? We get x is 2. We're in the same spot that we thought we should be in. Okay? On the second one, minus 2x equals negative 6. Divided by 2, divided by 2. Guess where we got? We got the result we need from the warm-up. Okay? It's just a process to do it in each case. When you it's an or, okay? Because it could be one or the other for it to be a correct statement. All right, let's go to number 4. We're going to do the same process, guys. We're going to take that stuff on the inside, whatever that stuff happens to be, and we're going to say that it's equal to positive 10, which is on the right. Then we're going to turn around and take that stuff on the inside, and we're going to say that it's equal to a negative 10. And I want you to go ahead and finish those two equations on your own. Okay? So right now on your end, go ahead and figure those two out. And then we'll talk about it once we are done. Okay, guys, hopefully you got this, where you got 3 minus 8x. 3 minus 8x, oops. minus 8x. That's the stuff on the inside. We solve these two problems. Subtract 3 from both sides. Subtract 3 from both sides. 8x equals 7. Right? And then divide by 3. Or divide by negative 8, sorry. Divide by negative 8, and you get x equals negative 7/8. Or, keep going. On the other one, minus 3, you get negative 8x equals negative 13. Divide by negative 8, divide by negative 8. Get x equals 13 over 8, and neither of those reduce. Those are two answers. What's up? I'm going to write or more evenly in the middle. Okay, let's go to two more that we're going to take a look at. Two more. A little bit different. Okay, guys, on number 5, what I want you to do without trying to officially solve it, okay, just in your head, okay, I don't want you to do official steps, okay, like an official process. I just want you to come up with, without writing anything down, I want you to come up with the two values for x on number 5. Okay, just kind of think about what the two values would be, and we'll write those down in a second. Did anybody get one of the values for number 5? X is what? Yes, sir. Negative 2? If we put in negative 2 in there, let's just see. Is that going to equal 2 minus 4? That's going to be negative 2. What do you mean? Like what x would be? So let's look at 12. See if 12 works. 12 could work. Does 12 work? Okay, 12 works. Great. There's another one. Did anybody get the other one? The other one is actually the other one's actually negative 12, isn't it? Absolute value of negative 12 minus 4. That's 12 minus 4 is 8. We're in the same spot.
So is it always like why is it sometimes not the same number as negative?
Depends on what the problem is.
But how do you figure that out?
How do you figure that out? Well, what I wanted to do on this problem was I wanted to let you know if you guys thought you could just split this up, right, and say that it's equal to that, okay, to do it. And this is not the right way to do it. And equal to that, equal to negative 8 over there. And you were to go to solve these, you would get 12 for the one on the right, which is okay, which you got lucky. But the one on the right, or the one on the left, you get 12. The one on the right, you actually don't get 12, you get negative 4. If you do it that way, which creates a problem because we know that it's not negative 4. Does that make sense? What I really wanted to do today with that was I wanted to just stress the fact that what you have to do first on a problem like this is you actually have to isolate the absolute value or get the absolute value by itself first. So to do that, you add 4 to both sides first before you split it to a positive one and a negative one. Does that make sense? Okay, we're going to do more of that tomorrow. I just wanted to kind of hint on that today and get your mind going. That's not on the homework though. But this is, can you have an absolute value equal to a negative number? Does that work? Can you have a distance that's negative? Because absolute value is a distance. No, so you can't have an absolute value that's a negative. This doesn't work. There's no value of x you can put in the absolute value to get a negative number out. Does that make sense? Absolute value can never equal a negative. This one's going to be a no solution problem. Because you can't have a distance that's negative, or you can't take the absolute value of any number to get it to be a negative number. No matter what you end up writing down in the absolute value, if you look at number 7, no matter what you wind up writing down for it, you can actually never get a negative. So no matter what's on the inside of that absolute value, it can never equal a negative. An absolute value can never equal a negative, so this problem would be no solution as well. Okay? All right, what we're going to do in class is I want you to get started on your homework with the time that we have available, with the time that we have left. Okay, so I'm going to show you, I'm actually going to show you the homework on the board. If you don't have your book, if you have your book, you can use it. But I want you to get started on the homework, and if you can't get to the correct answers, you let me know and we have a conversation about it. Okay?